Intelligent Communities Lifecycle. I'll let her speak a little bit more about that, but let's please welcome her. Thank you for joining us.
So thank you, Daniel, for introducing myself, and I'm very pleased to be here now today to explain you a bit more about our new Intelligent Communities Lifecycle technology, which is a new environmental digital twin technology that we have just launched on the market last April. So I would like to give you a brief introduction on this. So the plan for today is first to explain you what is the technology about and what we mean with IES Digital Twin, and then I will show you a nice story where we applied this set of technologies and we brought some savings for a specific case, and then a few final thoughts for as a bring back message from the presentation. So I don't know if some of you are familiar with IES. So IES is a Scottish company, 25 years old. So in the last 25 years, we have helped almost 1 million buildings in the world to be more energy efficient. So our core technology is called the virtual environment, which is a dynamic simulation software for buildings. And with this technology, as I said, we helped a lot of buildings and in the design phase and in the renovation phase to become more efficient. But with the latest challenges in climate changes and emissions of the built environment, we started thinking that one building at a time is not enough as a pace to achieve the targets that many countries and worldwide are being set. So we moved towards a larger scale, and we started tackling communities and groups of buildings instead of the single building, and looking both at their design but also at their operational performance. So when we speak about cities, districts, group of buildings in general, the challenge is also to make them more efficient and more performing and reducing their carbon emissions. The challenge is always not to have enough information for taking the right decisions, to assess the right plans for the community and for the group of buildings. So with combining dynamic simulations, so the physics-based simulations with actual data from sensors and from the IoT devices and everything, we can actually build up a very nice framework for understanding and predicting the behavior of the community, of any group of buildings, and also support stakeholders to take the right decisions and reducing the operational costs and reducing emissions and making the whole community more efficient. So this is exactly the goal of this intelligent community lifecycle technology, which helps you build a new sustainable digital twin for any group of buildings, which can be a campus, can be a group of buildings from a company, a portfolio, a city, a district, even a country, if you want. So summarizing, the ICL is a platform that helps you creating, planning, evaluating, and managing the performance of your community. So basically, our focus is not the design, not the construction, is the overall performance of the built environment. So we want to look at the energy performance, reducing emissions, and make sure that we operate our built environment in the most efficient way as possible. So it's a bit different focus from the previous section, if you want. So the concept of the ICL digital twin. So a digital twin is a virtual representation of reality in any context, okay? So in this case, we want to have a virtual representation of a group of building, any community, whatever, set of the built environment you want. And the characteristic of the digital twin is that it's a live representation of your building asset in a specific moment in time, in operation. So it's not just a collection of data as a snapshot, but is a live representation which takes into account operating schedules, actual performance in a specific moment in time. So how do you create this? You can create a 3D model by extruding from OpenStreetMap, for example. Then what you can do is you can start making a general analysis, generating data from simulations. And this is the actual USP of this technology, because it allows you, even if you don't have any measured data, to start populating your model with a kind of baseline performance, okay? So it's like having a million virtual sensors in each of the buildings, in each of the rooms, and which generates data initially as a starting point. So this is done through our virtual environment engine, again, but applied at a larger scale. Then what you can do is also, once you have data from BMS sensors, from IoT, from anything, any kind of time series data, you can bring them into your model and make it more accurate, and replacing the simulated part with the actual measured data. So your model becomes more accurate, become a kind of hybrid model, and then a calibrated model that you can use to test scenarios, to test different technologies, to test options, to forecast the behavior of the buildings and the energy performance in time, also coupling with artificial intelligence and machine learning to fill data gaps from sensors, for example, or to identify automatically faults or any problem in operation. So what you can also do, you can also share this information with citizens, with the stakeholders. So it's the ICL Digital Twin is also a very good tool for engagement. I thought it was good to bring a small slide on the difference between ICL Digital Twin and BIM, because it's a question that always comes when we start talking about this. So a BIM model, we have heard previously, like extensively, it's a very powerful repository for all building information across the life cycle. But the difference is that it's a static snapshot in time, okay? So it can be used, of course, across the full life cycle of the building, but it's not dynamic. And it's not showing performance. It's not performance-based, performance-focused. While the ICL Digital Twin, combining simulations and data, it's way more powerful, and it allows you to test different options live. So it's a live representation of your building in terms of performance, and it takes into account occupancy, schedules, operation. So it's a sort of wider extension of the BIM model, if you want. So this diagram represents the 6 components of the Intelligent Community Lifecycle suite of tools. So they are in circle because we start usually from a master planning level. So we want to look at a city initially, make a rough assessment of the energy performance, understand the impact of different options at scale, without going into much detail. And this is an example of what you can do with this intelligent community design tool, which is the part of the ICL dedicated to master planning. It's just an image to give you an idea. I can give you go into more details, but we don't have time now. But please follow up later if you need. Then you can start looking at specific buildings and make a more detailed analysis. If you want to retrofit them, if you want to assess, to design new buildings in detail, then you use the virtual environment, and you can, of course, go into very, very much more details and make more accurate analysis specifically. And of course, you can bring them back to the ICD model later on. Once you have your detailed model of the building, then you can start bringing in live data and look at time series, look at BMS data, look at sensors, and you make your building model operational. You make it hybrid, you make it calibrated, so you can actually test the impact of any technology and any energy efficient solutions, even in the operational, from the operational point of view, live in the moment. Once you have looked at buildings, you start moving at scale. So you start looking at how different buildings interact one to each other, how they exchange energy, how they exchange resources, how you can link them together for example, using a CHP system, what is the impact of adding electric vehicles charging stations in the district, what does it change in the dynamic of the network of the district, and this also allows you to explore more things about grid interaction and smart grids, if you want. So this tool is called the IVN, and actually it's exactly for this purpose. Once you have done all your analysis, you can bring everything together into this collaboration cloud, which is a digital twin where you can see all the results of the previous analysis. So all the tools provide inputs to this, and you can also add many other data. And this is a cloud-based visualization that you can use to share information with stakeholders, with people, and it can be a real digital asset live for your community, which goes in time and evolves in time. Once more data are available, once more analyses are done. So I now want to show you a case study, if you want. So it's a nice story, a collaboration we had with the Nanyang Technological University in Singapore. They have this project called the Eco Campus. The Eco Campus is a project where they aim at making their campus in Singapore one of the greenest campuses in the world. They had the goal to reduce energy, water, and waste footprints by 35% by 2020, and they wanted to do this. They wanted to test different technologies, and we supported them to evaluate the impact of those technologies at the campus level. You have here a few figures, if you want, on the campus, so it's quite nice and quite extensive, and it's really already a good set of buildings in terms of efficiency. So it's high quality buildings. So the first phase of the project was an initial master planning analysis to understand which buildings were more energy consuming. So you can see the different colors displays the energy consumption of the buildings compared to the baseline. So you can see in red are the poorly performing buildings, and in green are the best ones. Then we shared the same information in an ISIM, so in a campus information model, so people and students could access this. And we also, through this master planning analysis, we looked at very quick wins in terms of energy saving for certain buildings specifically, and we were already able to reach 10% energy consumption reduction only for this very rough analysis at the beginning. So after this, we moved to phase 2. So we took 21 buildings of the campus and we created detailed digital twins for them, starting from the VE. We created virtual environment models of the buildings. You see 6 here. And then once we had the building models, we made them operational, bringing in first utility bills and any kind of operational information we had, but then also BMS data and automated meter readings and time series data, whatever was available through our tool iScan. We brought it in to the model and we started interrogating the time series, identifying faults, for example, operational inefficiencies very quickly, just looking at the time series data. And this was already a very, very good way to spot inefficiencies and discover hidden energy savings potentials. Once we've done that, we now have a calibrated model, an hybrid model that we calibrated to check that it was actually a model corresponding to the actual building performance, and then we simulated different options. So they had 5 technologies they wanted to assess, and we simulated all of them, starting from this calibrated model, and we compared the scenarios in terms of savings, of course, but also payback and return on investment. So they could decide which one was the best to achieve their goals. And of course, this is ongoing now, but once they installed all the technologies they've selected, we could also monitor savings in the same way we did, because we monitor the building after installation and we bring data back to the model, and the model is now reflecting exactly the operation after the interventions. So this second step brought to 31% energy consumption reduction, And in terms of payback, you can see like all the 5 technologies we checked were below 7 years, so they've made use of this for like their investment planning. The last step we did was we started looking at different buildings and how it was more profitable to have a district cooling system instead of having single cooling systems in the different buildings. So using the IVN tool, the Intelligent Virtual Network tool, we looked at different aspects and different scenarios, and we compared, for example, CO2 emissions of the 2 cases. So the blue one is the case of a district cooling system installed, and the orange case was the single buildings systems option. So you can see that without investing, you can initially immediately understand that one option is way better than the other one. So I have now a short video to you to show like what people there thought about this. So give me a second, because I need to.
My name is Nilesh Jadhav. I'm the Program Director for the Eco Campus Initiative at NTU Singapore. NTU aspires to be one of the greenest campus in the world in terms of sustainability as well as in terms of smart technology implementation. The Eco Campus program is a living lab program which aspires to have a combination of research, demonstration, test bedding, and using our campus infrastructure for the same. Using this ICL technology, we were able to see how different technologies play a part synergistically in reducing the overall energy intensity of the buildings on the campus. The project that we worked with IES consisted of 2 phases. Phase 1 was about master planning, which is the intelligent community design, and the city information model from IES that we used on the campus buildings to represent a virtual model of the whole campus. This master planning model gave information about the campus buildings and its different parameters for sustainability. Using this model, we were able to see the impact of technologies that's running on the campus in a virtual environment and see how they could lead to achieving our objective of a 35% reduction in our energy intensity on the campus buildings. Using this modeling in phase 1, we were able to identify some quick wins or quick ways to reduce the energy intensity on the campus buildings. And we in fact achieved around 10% of savings during this phase. So in the phase 2 of this initiative, we did a detailed calibration of 21 buildings on the NTU campus in the IES virtual environment, and subsequently we tied it with the scan product from IES to get a data integration and calibrate the models in a very detailed way. The helpful thing about the ICL technologies is that we are able to integrate in the virtual environment all the different test bedding approaches that we are trying on the campus. This gave us a very good overview of the different technologies that we are test bedding by providing accurate estimation and quantification of the energy savings. Through this overview of technology integration, we saw a potential of about 30% energy savings, and around $5 million of energy savings per year could be uncovered thanks to this process. Being a research project, it was important for us to collaborate and work together with the IES team. We would recommend ICL tool to other companies or campuses which would like to get an overview of their energy saving potential and also do a very systematic and rigorous analysis of the energy saving potential with the different technologies that are coming up.
Okay, should be fine. So here, I need to do this, otherwise, okay. Okay, so that was like just to show you an application where we applied all the technologies of this ICL suite of tools to a specific community, which wasn't a university campus, but the applications are actually a lot and very different one to each other depending on the specific needs of the final user. So I made a small takeaway message slide for highlighting what are the main points of what I presented today to you. So the first point is that the ICL Digital Twin is focused on performance. And so it can support stakeholders and actors and service providers and even contractors to understand the impact of different options virtually before investing in a specific solution and taking into account energy from the very beginning of a project. It helps in identifying where to spend money, where to act in order to improve the sustainability of a specific community. And it also, the key point is also that it leverages the best of the physics simulations that are our core USP with metered data and machine learning, allowing to get the most out of a virtual model of any community. And also, it's very flexible set of technologies that can be used on their own or all together and are interoperable among one with each other, and they can be customized for different use cases and different end users as well. So, if you want to know more, you can visit our website or come to me, and I'm happy to go through this. Thanks.